And first up is Amanda Tomei from the Digital Research Alliance of Canada. So, Amanda, if you are ready to rock and roll, take it away. Please start sharing your screen. I'll let you know if we can see things. It's looking good. I can see your title slide, so it's all yours.
Okay, cool. I just want to put a link in the chat. Hopefully that'll all work.
That's appeared, yep.
Yeah, okay, cool. Um, all right. Hello everyone. I'm Amanda Tomei, the Digital Preservation Coordinator for the Digital Research Alliance of Canada. And today I'm going to provide an overview of our draft workflow for creating a file listing for the data sets deposited in the Federated Research Data Repository, or what we call FRDR. So during the time we have together, we will first go through a broad workflow overview, go over a glossary of some of the terms that will be used in the workflow description, discuss why we need to use the HPC environment, the setup that is needed to be in place before we could start developing the workflow, and then spend the bulk of the time reviewing the workflow and next steps. So this is a draft workflow for creating a file listing for datasets in FRDR from dataset publication all the way to the next stage, which is appraisal. I realize you likely probably can't see this workflow in great detail, so I've provided a link in the chat to a PDF version and you can zoom in as needed. Broadly speaking, there are two main environments where processing work takes place: the high performance computing clusters and scripts run in the local environment. And I've tried to keep this to 10 hopefully very easy steps. The file listing that we are creating with this workflow functions as our digital asset registry. It gathers important information about the files in the dataset, which allows us to have control over the files slated for preservation. It feeds into the digital preservation action plan, the risk matrix, appraisal decisions, format identification, our format policy registry, and more. As such, the file listing forms the foundation of much of the digital preservation work we undertake. The final file listing includes the dataset publication ID, which is used internally, the file path to the individual file, the format identification results, and the file extension. I'll be using terms today that some of those in attendance may not be familiar with, and that's cool. I'll provide a brief explanation when we encounter the terms in the workflow, but I thought I'd provide a glossary of terms as well. So we have high performance computing, HPC, or clusters, which are powerful computing systems composed of many interconnected computers called nodes that work together in parallel to solve complex data-intensive problems much faster than a single computer could. The primary point of access to the clusters are the login nodes, and the login nodes are a shared resource and only meant for lightweight tasks. The compute nodes are responsible for executing the bulk of the compute workloads. The compute nodes are optimized for performance with large CPUs and RAM allocations. And then we have Secure Shell, or SSH, which is used to create a secure connection between the local and remote servers. And then Slurm, or Slurm Workload Manager, which is a job scheduler used by supercomputers and compute clusters. So using HPC clusters to generate a file listing may seem a bit over the top, but there are a few reasons why the workflow must include this environment. The Alliance and its partner sites are a distributed workforce deployed across Canada. For Alliance staff in particular, this means we are remote-first employees spread out across the country. The Digital Preservation Services team includes staff in Quebec, Ontario, Saskatchewan, and British Columbia. The way the Alliance came into being, which was kind of an amalgamation of various entities, means that the services and products were already residing with many of our partners' infrastructure. No centralized infrastructure was implemented, so Alliance staff don't have access to a basic server space to use to complete work. All we have is our laptops, which would normally not be a problem unless you are working with large data sets that continue to grow in volume and number of files. The graph on the slide demonstrates growth of datasets in terms of overall size over time. There are some dips. I'm not really sure what happened in 2023, and some spikes. We do know what happened in 2024. And despite the highs and lows, we are experiencing more deposits and larger deposits per dataset. This means that datasets are too large to be transferred to a laptop. Therefore, the only option we really have to create a file listing is to use the HPC environment. Now, before we get started and dive deeper into the workflow, I want to first touch on the items that are not in this workflow, but were necessary to make this workflow possible, namely the collaboration between different staff and partners to get the software installed and our allocated space implemented. So the first step was to work with our partners to investigate if the file format identification tool Siegfried could be installed on the clusters. Researchers are allowed to request the installation of software or install software themselves. As we weren't sure if we could use the environment for our work, we decided to reach out to a HPC specialist from Quebec. The request to install some digital preservation tools on the clusters was well received, and we opted to start with Siegfried as that was the tool that was needed to continue on our journey. Siegfried was installed cluster-wide in September 2025, and the fact that the tool was installed cluster-wide is significant. This means that the tool can be used by anyone with access to the clusters, and this includes RDM practitioners responsible for digital preservation. We also needed increased storage allocation and a space that can accommodate millions of files at once. We put in a request to our operations team to see what resources were available for us to use. The suggestion was, in the short term, to have a resource allocation project or RAP space set up for the further team. A RAP space is a space that has a designated set of compute and storage resources assigned to a group or research project. Our space includes 50 terabytes of storage, 50 core CPUs for processing, and has space for about 5 million files. This space is shared between digital preservation services and curation services and can be expanded if needed. The wrap space becomes important for step 3 of this workflow. It should be noted that by default, each user on the cluster is allocated nearline, project, and scratch space. However, digital preservation services in particular kept on hitting the ceiling for file count on the default spaces. For our purposes, the nearline and scratch space are immediately excluded from the workflow, as nearline is tape at the Alliance and the scratch space is a 60-day purge policy, which is often not enough time to complete the work as we get pulled in many directions. Therefore, only project and the wrap space are used in this workflow. Lastly, on our Getting Ready tour is developing new skills. It was great to have the spaces and tools in place, not so great that no one had ever submitted a job to the clusters. So first, submitting a job to the clusters mean that you submit your request with your scripts using a specific command. Slurm, the job scheduler, will then review the request, the memory needed, and the time it will take to complete the job and schedule it based on the parameters in the scripts that was submitted. As the clusters are used by thousands of people on any given day, using Slurm Job Scheduler ensures that everyone gets access to the resources, but the resources don't get overloaded. We also had access to one of the training coordinators who was generous enough to meet with us, answer our questions, and supply training resources needed. Next, we had to craft Siegfried as a script so that it could be submitted as a job. Working with Siegfried in the command line is not a problem. Submitting Siegfried as part of a job was producing error messages. To help solve this challenge, I reached out to the digital preservation community on Mastodon, and with the help of Richard Lehane and Andy Jackson, was able to get the format identification going. So with all that context and setup explained, we can now focus the rest of our time on the workflow itself. This workflow is still a work in progress. So the workflow starts with the publication of datasets and further. Once the dataset is public, curation processes have completed, and the dataset moves to the preservation queue. The first part of this workflow involves assessing whether a file listing already exists. This was more common in the past, however, workflow changes from other parts of the repository mean that this is increasingly rare. If a file listing is available, then the dataset moves onto appraisal. If a file listing does not exist, it moves into the file listing status in our Jira board. So Jira, a software that tracks issues, is used to track the status of datasets from deposit all the way through to long-term storage. It is also used to divide tasks between members of the team and to report and track issues with datasets. Now, before we begin moving files around in various systems, there is a note on the workflow diagram that reminds the person undertaking the work to verify the status of various Alliance systems. If the system needed is down, then an alternative system may be used, or the person will have to wait until the system is back up, as that happened today. This is noted as a step in the workflow because we often start the transfer process without reviewing what is available, which then involves terminating the process and starting again. Once we have determined that the dataset needs a file listing, we need to now consider the size of the dataset, as this will tell us which location to use to generate the listing because, as mentioned, different spaces have different storage criteria and limits. In general, if the dataset is under a terabyte, it can go to the project space. If it is over a terabyte, it must be transferred to the wrap space. When a decision is made, it is recommended that the final location be recorded in the Jira task as we get pulled away with other priorities, and it may be a while before we can come back to working on the dataset. Once we have taken all the criteria into consideration, our options are to transfer to either FIR or Narval clusters. Other clusters are available, but recent changes mean we now have to opt in to use those clusters instead of having access to all the clusters by default. FIR is needed because it holds the wrap space. Narval is a secondary space that can be used. And I should say Narval is the French for narwhal. Calcu Quebec names all of its clusters after whales, so narwhal, beluga, rockwall, and out west they named their clusters after trees, so fir, cedar, arbutus. Transferring of files is completed using Globus Transfer, a tool developed by the University of Chicago that provides both command line and GUI interface to reliably and securely move, share, and discover data. While we call it Globus Transfer, it is actually creating a copy of the files and then moving them to another destination of our choosing. The original files never change location. Globus offers many different settings that a user can select prior to transfer and completes integrity checks when the content has transferred. If an error is detected, a notification will be present in the activity pane of the GUI. And it's at this point that we begin using the HPC environment for our work. Once the transfer is in progress, we can SSH into the clusters and initiate the transfer scripts that we've developed if they are not already at the destination. I like to leave the scripts in a directory at the root of the different spaces we use and modify and run them from that location. After some experimentation, we found it was easier to modify the scripts so that it took the file path to the directory as an argument instead of moving the scripts into different directories. Once we have connected to the clusters, we can navigate to the directory where we find our scripts. At step 6, we have another decision to make. If the dataset is smaller than 10 gigabytes, then the file listing can be run on the login nodes, which are meant for lightweight tasks. Scripts may need to be modified slightly, but can be executed in the terminal and will run as long as the connection stays open. This option is available, but is not frequently used. The preferred method of generating a file list is to submit a job to the cluster. Doing so has the added benefit of getting an activity report. It also has the benefit of not requiring the user to be connected to the cluster after the job is submitted. To run a script on the login nodes, the user can modify the script if needed using Nano or another text editor for Linux. The file is saved. The permissions are changed using the change mode command to make the file executable, and from there the command is executed. The process runs until it is complete or until the connection with the server is lost. The preferred method for generating the file listing is to submit a job. The process to submitting a job is not dissimilar to executing scripts on the login nodes. However, the script needs to include certain information that the scripts executed on the login nodes don't need. So on the right-hand side of the slide, there's an example of the different components of the script. So at the top includes the shebang, which tells the operating system what interpreter to use for executing the script, and we tend to use bash scripts. The next block of text outlines the account submitting the job, the number of cores to use, default is 1, the memory needed, and the time needed to run the job. The account will need to be changed depending on where the user chose to transfer the files. The memory needed and the time needed to execute the script will likely need to be changed. Changes can be completed using a text editor for Linux. The user may also specify a different error output file in addition to the output file that will contain the format identification results and include their email so they may be notified when a job starts, when a job ends, or both. The job is then submitted to Slurm Workload Manager using the sbatch command. From there, the scheduler will place the job in the queue. If the user has opted to receive an email notification, the one will be received when the job has been queued. And it's really important to note that if the memory or the time is misjudged and this job fails, the script will need to be updated and resubmitted. Once the job is complete, we move on to step 8. If the job is completed and was submitted on the login nodes, then a CSV file of the file listing already exists. The CSV is then transferred to the local environment and the datasets move on to the next status, which is appraisal. If the listing was submitted as a job, then there is one more action that needs to occur before moving the dataset to appraisal. When the file listing using Siegfried is run as a job, the identification of files is outputted to an output file, so a file with a .out extension, and this output file is turned into a CSV using Siegfried's replay option. Once complete, the CSV is transferred to the local environment and the dataset moves on to the next status, which is appraisal. The output we get needs to be manipulated in order to mirror the file listing we received in the past. This is done by putting the CSV through some scripts written by Digital Preservation Services. At this point, we can also update our format stats, which will provide the service with a list of extensions and formats along with the number of files and further associated with each. If formats were identified as unknown in our file listing, then a CSV for each unknown extension is generated for further analysis. If everything in the dataset was identified, then the process comes to an end. When the process is over, we have our final listing, which is very basic but forms the backbone of much of the digital preservation services work. The listing includes digital preservation service listing and provides rather digital preservation services with information that allows us to evolve our practices, make informed decisions, and be transparent in our approach to the preservation of data sets. And as this is a draft workflow, there are some areas we would like to improve to make the process more efficient. So one of the areas we would like to explore is to use a job array. If your work consists of a large number of tasks which differ only in some parameter, you can conveniently submit many tasks at once using a job array, which is also known as a task array or an array job. The individual tasks in the array are distinguished by an environment variable, which sets to different values for each task. Submitting a job array may potentially save the time as jobs can run simultaneously. It would also cut down on the number of times staff have to connect to the clusters to submit jobs. We would also like to investigate using FIR's Jupyter Lab integration to run our file listing cleanup scripts so that everything can be done in one place, which could potentially cut down on transfer points in the workflow. Another option would be to investigate modifying the Siegfried script to incorporate the replay option once the file listing is complete. So that's our workflow. On the slide, you can see the output that is generated from this workflow. It looks basic, but I consider it quite mighty. I would like to thank everyone for their time, and I look forward to the question and discussion period.
Wow, thanks, Amanda. Yeah, everyone's anticipated that I was going to ask for a virtual round of applause, but it's silently sweeping around the Zoom room. Thank you very much for that. Well, I see Susan Border has given a shout out for Globus in support of that, so thank you for that. Does anybody have any immediate questions or responses they'd like to put to Amanda? Feel free to just sort of unmute and speak up. Hopefully we won't get too many people at once. Oh, there we go. There's Susan already in the chat. Just how do you handle odd file types from proprietary systems?
So when we do that analysis part of when we clean up the CSV sheet and we do that kind of we look through the file listing and we look for anything that's unknown and also anything that may be identified and as something but doesn't really look like it should be that, we kind of create a new listing and then we do a format analysis identification and we have a separate workflow for that. And through that process, we actually have identified about 375 file formats. About half of those were not in Pronom, so Siegfried did not identify them. And we find for data sets kind of like that are more scientific that a lot of the misidentifications are actually as plain text. So a FASTA or FASTQ file will be identified as plain text, which isn't, I mean, you can open it in a text editor, but it's not the file type. So that's what we've been doing. And actually we've been adding those to our preservation action plan, which then feeds into our format policy registry so the rest of the community can see what those formats are. And we also submit the signatures back to Pronom if there's a signature within the file.
Okay. So is it fair to say then that the number of sort of odd and unusual file types you're finding is diminishing? The researchers being better behaved and adopting standards or telling you what they're doing or what?
Yeah, that's a tricky one. I know that from our perspective at the repository, the recent count was that we still had about 480 files that couldn't be identified and about 70,000 with no extensions. And I'm honestly like not sure what to do with those. So if anybody has advice, please put it in the chat. But I think we're starting to see patterns of what file formats are used by certain disciplines, and that's something I kind of want to do now that we have a better hold on the workflow for identifying the formats and getting that listing, the format identification process. And now I think the next step is using the domains that are listed in the repository and cross-referencing them so we can have a better understanding of what's being used by which research domains.
Thank you.
Yeah.
Yeah,
Yeah.
yeah, second that.
Yeah. Thanks, Susan.
Well, perhaps whilst everyone else is cooking up a question. So I'm sorry if I missed this, Amanda. Um, how do do your staff all write their own scripts, or do they pick from a library of scripts? I mean, how kind of technically competent? Not competent. That's the wrong
Um,
word. You're capable.
yeah, yeah.
Are your staff, or is it does everybody have to be
So
scripting
we're
whiz kid
not
or what?
So we're not, so our staff so our developers are shared by the rest of Furter, so we don't get a whole lot of time with them. And our other staff person is contract. So it's basically just me who is full time. And so actually what happened was I've been telling myself I need to get better at scripting things. And then I was sick for a staff retreat. So I ended up being at home while everybody was at the staff retreat. And I had a week of no meetings and just taught myself how to do things. So they're all in-house developed. I don't know that they're the most efficiently developed. Like they probably could be looked at and improved. But yeah, everything's in-house.
Okay. Megan says she's nodding vigorously with her camera off, so that's good. Um, so I think earlier on you were also talking about how the allocation of resources, you said, it can be expanded. Could you maybe say a little bit more about that process? Is it one of the things where people have to sort of know in advance and submit a request and wait for it to be approved
Yeah.
and things, or does it kind of like, is it clever enough to sort of work things out automatically and say, okay, here's a great big audio visual file, I'll adjust for it.
So no, we have to tell it. That was one of the issues we were having. So basically, when the tr people when researchers go to the clusters to submit jobs for their analysis or whatever they're doing, they actually kind of already know what time and what memory to allocate to those jobs because they've
Hmm.
done it a million times. For us, because we don't own the data sets, it's kind of like, well, I think this might take 2 hours, but I'm not entirely sure. So we have to like benchmark kind of different scenarios so we can submit the jobs and it wouldn't fail. Now, for the wrap space itself, that allocation would have to be a request to our operations team, but we do have statistics that we can monitor to see if we do need that extra allocation, and we can use that as part of the request.
Okay. And on that note, do you have a sense of how often jobs fail? I mean, do they, more often than
Ooh.
not succeed, or is it like a tiny, tiny percentage, or is it
At the beginning, it was
diminishing?
like
Yeah,
everything, but
yeah. Okay,
um, no, I think we're getting better at like maybe 5% fail out of the gate. But
okay,
the clusters too, I say are a bit finicky depending on the day. Like a job that, well, let's say we allocate 100 gigabytes and an hour to can be finished in 5 minutes, and then the same sort of data set can take 3 hours in timeout. So
okay,
it can be a bit finicky.
okay. Thank you. Well, Susan's been busy in the chat again, and she's just saying, uh, do your submissions come with README files?
I missed being.
She's
Yes, they do. Yeah.
okay. And do you do anything special with those, or do they just sort of
No,
get?
the README files are all text-based, so there's nothing really special. Although preservation services does treat them differently than curation services. So we include them in our file listing because we consider it as part of the data set, whereas the curators don't include it in their listing because it's not a part of the data itself. So we kind of look at them in two different ways. But the README contains the bulk of information needed for others to use the data set, so we consider it quite important.
Okay. And I'll pose one last one since everyone's being so coy. So we often a common theme that emerges in conversations that the DPC has is around essentially environmental impact, broadly defined. So do you think have you got any evidence whether your approach is more efficient and is saving the environment, or is it like, melting ice caps because it's huge, great computers spread about, or does
Yeah,
it depend? I guess.
I don't think we're melting any ice caps, but don't quote me on that. I think our our HPC specialists are very in tune with the environmental impact that data centers, the risks that they pose to the climate. So they are aware and they implement things to help mitigate some of those. So like when we did a soft hardware refresh last year, and one of the cooling mechanisms that's now being used at a cluster in Ontario is actually the servers are submerged in oil to keep them cool,
Mhm.
instead of, blasting the AC. Because I've been to some of those data centers and it is hot and it
Mhm.
is loud. So do we have an environmental impact process, like assessment process in place? No, but that would be something we would want to look into, because it is quite important.
Okay. And do you think have you got any plans to sort of open up your infrastructure to sort of, I don't know, other interested parties in Canada or even, further afield?
From a digital preservation perspective?
Yeah, yeah.
Yeah, so already most of the people I work with in research data management actually have an account that would allow them to have access to those clusters.
Hmm.
It's just mostly a training thing now that don't always have, they're wearing multiple hats, so they don't always have the time to sit down and train. So we are looking at training to see what the community needs, and hopefully being able to use the clusters, or what we have something called Magic Castle, which is a virtual, um, it spins up a virtual environment so you can use it for training that doesn't take away from the cluster resources. So we would likely do training in that, but that would mirror what is exactly happening on the cluster. So yes, we want to open it up more, but we have to get past that training hurdle.
Yeah, yeah. Okay. Well, I'm not seeing any more questions coming in on the chat, and I should bite my tongue and spare you any more, Amanda. I see Susan just putting a plug there for women in HPC as a group for um, women who want to learn more about high performance computing. So I don't know it myself, but I'd encourage you to check it out if you're interested. But thanks again, Amanda. That was excellent, and for getting everybody off to such a good start.